Hello everyone, it's nice to be here. Let me start by introducing myself, and also if you will not hear me, please let me know, because I already learned that sometimes you have a presentation and somewhere in the middle you're learning that just because you have a mic doesn't mean that people are hearing you, so just in case, let me know. Okay, so who am I? I'm working with Scala for about 10 years, so I know this is kind of unusual here, but even though I'm going to use examples from Scala, you don't have to be Scala programmers. This presentation is not about Scala. I try to be as technology agnostic as possible. As a Scala programmer, I am also working with Chimney library, which I'm going to mention during this presentation, but again, it's not an advertisement. Probably by the end of the presentation, you'll learn why you don't want to use this library or any similar, but at least maybe you'll enjoy the presentation anyway. I was also sometimes blogging about Scala and writing a book on Scala, but those are just minor details. So what I wanted to talk about today is about data transformations. And this is a very vague term, so we'll start by explaining what kind of transformation I mean, where are they used, what are they for. Then we can move on to, okay, can some of them be generated? We all show why sometimes you might want to generate them as opposed to writing them by hand as same people. This presentation was originally submitted for Lambda days, so the idea was that everything that you're talking about there should be mathematically based, because concepts which are purely making business value are not interesting to those people. You have to also show that you are doing something principled. So we would like to try to prove that this transformation generation can be principled. And some people would automatically believe that if it's principled, it means that it's easy, that it's reliable, that everyone would understand how we're going to use it. And that will be our last point, that just because something is principled and you can describe it with mathematical precision doesn't mean that it's going to be working out always the way that you want it to do. Okay, so let's start it. What kind of transformation we're talking about? And I'll start with some motivating example, or for some people, demotivating example. Let's say we have some API to domain to database conversions. You're writing your everyday backend, you're receiving some JSON, you're deserializing this JSON, sanitizing the data to make sure that nothing nasty is happening. You push it to your core domain. This core domain is doing some computation, making sure that nothing that happens nasty inside. You transform the data inside, you get some final result, successful or failure, whatever, and then you try to save it to the database. So, okay, this is going to be a lot of code. Sorry about it. So those are the case classes, which are basically your record data from the Scala. This is basically what you can see. You have a class, you have some field defined, you can pass it around, it's immutable data, you can modify it. It automatically generates handlers for equality checks, and for printing it in the console, and also for pattern matching. So basically a record data structure. And we can see that we have some user, and this user has ID, this user has some data, and whatnot. This is something we would like to store in our core domain. But for some reason, we also would like to have some completely separate record type for the API. Maybe it's generated by some Swagger generator. Maybe we want to have API nicely versioned with one format and keep domains separated so that no small change in API will immediately pollute and go into our core domain or whatever. There's a lot of reasons why we want to have those two models separated. And then we also want to write to the database. And when we're working with database, we want to abstract and fetch records. It's easy to have a flat data, nothing nested, nothing, very, very good for a human to read or display or traverse or whatnot. Usually the best way to store database data and handle writing and reading data is having some flat row of records. But it isn't necessarily good if you want to read it and maintain it as a core logic. Inevitably, if you would like to write some controller like this one, let's say this is some endpoint. We are posting the JSON. This JSON is some sort of string. We are having some ID as a part of the URL. We are parsing the body. Okay, so we're receiving some user API on the happy path, and we could use it inside a map. Or if it's a failure, then we are short-circuiting and going straight to the error, because we can use this nice little result format either. It's coming from Scala. Hopefully, I'm not overloading your mind. Basically, the idea is that you have something like either the result is right or correct, or the result is failure. If it's right, you can map over it just like you could be mapping over the list. And if you fail, then those maps are basically no maps. You're just passing it under the hood. So those triple question marks is like a way to signal that, okay, this is not a real implementation. We're just showing you that we would have to put something here, and it would should type checked if you compile it, but right now it's just a placeholder. So we can see that after parsing the body, we have some user API, if it managed to parse things correctly. Okay, we have the user API, but we want to convert it to user because we don't want to use the representation meant for JSON inside our domain. Okay, now we get the user meant for our domain. Maybe we're doing some operation with it, maybe we, persisting it, caching it, whatever. After we're done with it, okay, we want to persist it. So we're converting the user to the user DB, meant for some repository or whatnot. And then we are using this persist user methods to try to persist it. Hopefully I haven't lost you already. So the biggest issue with this kind of code is that most of people who look at it is like, okay, this is too much boilerplate. There's more code about converting back and forth between those data types than it was about the actual domain logic. So I can understand that you might want to have separate representations because your database library prefers you to have a separate model for this one, and your HTTP library prefers you to have a separate model for this one, but right now this controller is all about converting back and forth, and it's very, very annoying. And if you try to implement it, well, this logic is very mundane because all of these fields, they look like almost exactly the same. They have the same names. You're just passing them around. And if you're unlucky enough to have this, poorly typed representation where everything is string, or everything is integer, or whatnot, it is very easy to just swap those fields around and make some very, very silly mistakes. Also, what if the number of the fields grows? You would have to edit every single of those places. And as I said, what if those fields are reusing the same primitive type? What would happen if we are doing some refactor, reorder those things, and unfortunately type checker wouldn't count it because, well, we have strings everywhere. For instance, let's say this class grew to this size, and we are converting from API to the domain representation, and suddenly, oops, we swap those two fields together and nothing complain about it. Unless we have some solid unit testing, we will not catch it. And this is the code that we didn't want to write in the first place. So maybe let's use a code generator. So let's assume that if we have some source value, we want to convert it to some target type, and we are using some strongly typed language in which we could somehow access the schema of the data. So to know their shape, to know, okay, this type has this kind of fields, those fields have this kind of type, so we could actually, have some reasoning about how those fields, how the data will be shaped in the runtime without actually checking in the runtime, because sometimes it's late and sometimes it's like, not really effective to do those things in the runtime. Okay, so we have the schema for input and for the output. So let's assume, okay, we have those record types. Those record types have some fields. So if for every single of those fields we can resolve the value that should go into this field, we could call the constructor. Nice. How could we try to find the input for every single field? Well, we maybe use some conventions like if the names match, then we use it. And if there's anything extraordinary, like the name of the fields are different, or there is some field missing, you have to provide it explicitly. So let's look at this code. It's unfortunately for this little code that we have, you don't see any benefit of it being, shorter. The benefits only usually appears once you have those transformation of, a lot of fields. But it's slightly better for us if we think about, long-term maintainability. Like, we don't see anymore that we have to, write about every single field. So if we add a new field to the API and add this new field to the database and add this new field to the domain, this should compile still. If it won't compile, it should tell us why it didn't compile, what did we miss. So, and also there's less risk of something that forgetting that we need to initialize some name or mistaking some fields, because this automat would not have the same issues that we have, that it will not mistake or overlook that those fields are having the wrong names. So yeah, basically we were able to use some way of giving some code generating information that as long as it can access some schema, it could safely generate the code that would be safe to run in the runtime. And maybe even catch some errors either before we run the program during the compilation and whatnot. So this is the reason why some people might use this kind of code generators. I'm not going to advertise it. I'm just going to tell you that I wrote one of those code generators, and I learned about some challenges when it comes to implementing this stuff in the practice. So one of the reasons some other people are using this kind of code generators is not only because they are saving the boilerplate, but also because those people feel it's more of a declarative programming. Like if we had this kind of records, you can see they're almost identical, but the second one has some extra fields. If we wrote the code by hand, well, there is a lot of code. There's a lot of noise. We only see that when you see this field, use this field from the input. When you see this field, use this value from this input. When you see this, etc. So there's a lot of noise. Some people would like to have this noise in their face because they want to have all the code committed, whether they write it by hand, or whether they have some slaves in the basement, or whether they have some ChatGPT. But they would like to have this code in their face and committed. But even if you have it committed, even if you can look at it in the IDE, you still have to review it. And if it was not 10 lines of code, but 300, because some people have this kind of code bases, not by their choice, I'm guaranteeing you that you wouldn't catch issues during the review. You only can catch issues by writing tests. And if you can only catch issues by writing this, then you might as well use something like declarative programming, because this is actually declarative. If you had this kind of the ESL said something like, okay, I have this value. I want you to give me the transformation which would take this value and return this kind of type, doing the least amount of work necessary to invert it. When you see this field, hard-code it to this value. When you see this field, hard-code it to this value. When you see this field, you can compute it using this function. And for everything else, use a field with a corresponding name. If you are able to resolve that, give me this function. If you cannot do this, give me a compilation error why you cannot do this. So if you look at this problem from this point of view, a lot of people are invested into those libraries because basically they're like a runnable documentation what you want to achieve. You're not writing every single little piece of the transformation, you're writing some declarative descriptions what you want to get. Sometimes it's super boilerplatey, but that's another issue. But those are like two reasons some people might want to use this kind of transformations in languages which are not using structural typing, I have to admit this. So usually you have these issues when you have nominal typing and strong static typing, etc. Then you have to actually convert the data the way that we are doing this. Okay, so we see why some people might want to do it, to use such kind of libraries. So is this library some sort of a hack, or is it following some principles? Well, and also like how this transformation can be generated. So in Scala we have macros and metaprogramming. One of the examples is the library that I'm maintaining. In Java you have annotation processors, which are somewhat cursed, but Java developers love them. I can't really tell you if you should consider them something which runs during compilation, after compilation, whatever, but they are being able to generate some code and make sure that if there are some issues, they'll learn about them before the deployment. So you have that. Some of those libraries are using runtime reflections, some are using bytecode generation to make sure that you are not doing some expensive computations for every single of these transformations, but you just analyze this type once, generate some bytecode, and then use this bytecode to make it like more lean. In C# there is reflection emit package, which is employed among others by Automapper. There are some expression trees used by ExpressMapper. In Go there is copier library, which is supposed to making struct-to-struct copying, but it's basically the same lane. And Swift is using runtime reflection with the converter library to also achieve this kind of goal. So a lot of different ways to achieve the same thing. Convert the data, one type into another type with as little work from you as possible. And I am highlighting that because I don't want to talk about particular way of generating the code. I only want to talk about what this code generation engine that you are using would have to do to give you the result that you want to get. Like without looking at a particular technology, because that's a topic that you could discuss for a whole month, and it's not probably very interesting to a lot of people. So we were saying that a lot of those things is like a declarative programming, and there is one language which is very declarative, like it's called SQL, so let's digress a little bit. Again, this presentation was supposed to go for Lambda days, so we cannot talk about, stuff that everyone knows without giving a lot of math that is completely redundant, but which makes it sound super smart and principled. So before we got SQL, long time ago, as I learned yesterday on Wikipedia, a few guys started doing something like calculus of relations, but it was at a time when mathematics was only started being formalized. So some other guy had to propose the first axiomatization, and then Edgar Frankfurt wrote a relational model for data for large data banks. So it was on one hand very mathematical, on the other it advocated that yes, we are doing this for the business reasons, because we want to get paid. And some other guys were inspired by his paper and implemented the first SQL engine. One of them was Donald Chamberlain, the other was Raymond Boyce. And if you see the names Boyce and Code, you should get the PTSD from passing all of those exams about SQL during your uni studies, because normal form Boyce code is like one of those things that you were asked about when you were normalizing databases and tables. So all of the stuff, like really old, it's 50 years already, I guess. So what is relational algebra is really about? Well, basically it's just set theory with extra steps. So records. when we are working in SQL, we get used to this idea that we are just looking at the tables, rows, columns. Every single record is a separate row. Columns are telling us what is happening inside each cell, but this is not very mathematical, so we can use this description. It would confuse people from the uni. So instead we are saying, okay, we have a set of tuples. Each of the tuple has a fixed set of values inside for this particular set. And we are expecting that this particular data in each of those tuples will be on this exact position. But mathematicians don't like you to fix things on numerical positions. It's not very flexible. So like when we have those this set of tuples, we also have something called a header. What is a header? Well, header is a tuple of functions. Okay, what kind of functions? Well, basically, we define this function in such a way that, okay, you have this function that when I will give you this record, this element of this set of tuples, give me the first element of the tuple, or the second element of the tuple, or the third element of the tuple, and then, for instance, we can give them some names. Like if we have some users set, which would have ID, name, and age. Mathematically speaking, there's just strings and numbers in some set of tuples. So not really nice to use, not really pleasant. So let's create just some functions named ID, name, and age. Then let's get some row. And just by calling those methods, those functions with this row, we're just extracting these values. And this way, instead of working with indices, positions, etc., we can use user-friendly names. So this is some super mathematically fancy way of saying that, yeah, when you are working with SQL, it doesn't matter how you are storing data internally. You can just use user-friendly names and reorder them around, and it doesn't matter if you are querying names in order that they stored internally, or if you just reorder those things. We don't care. Just use whatever order you like to use. Selection. So selection is basically this part of the SQL when you are filtering by some predicate. And mathematically, we obviously have to describe it in some fancy way. That let's take each tuple of this set we're working with, apply the predicate, and if it's true, then it is a part of our selection set. Or we can just show you the SQL. Yeah, this is just a cell with some where clause. But we can just, we can use this on the Lambda conference. It would be too business-oriented. It wouldn't be, allowed. Yeah, the example with the users, we can define fee using our headers, use attributes. So we are using age instead of saying let's take third position of this tuple. No, we are working with something nice. We are working with attributes. And then we can just say that, okay, when we apply this predicate to the users set, we will receive those users which have age above 20 or whatnot. Which is again very fancy way of writing word class. Projection. This is another fancy name for basically saying, okay, when you have a record, you have all of the attributes. Maybe you don't need all of the attributes, so let's define some subset of them. So we have the subset of all possible attributes. And then we define this projection function, which are picking the values of each of those subsets, or as people from SQL says, we just having select without the star, we just using the attributes to extract things. Again, some example that we can just relate to rename. It's really called this way. No fancy name for the rename. It's just called rename. It basically means that when we have this set of attributes, which is a way of using some named function to extract data, we're changing their names. So this one is basically saying, yeah, when you have this set of names of the columns, when you see the column name A, use the name B. So when we'll be referring to as B in the SQL, we actually mean A's. And it's basically us when we are using this SQL. And of course, because all of that is just super hand-wavy way of doing set theory with extra steps, we have to also have Cartesian products. So assuming we have two sets of tuples, and those sets have disjoint headers, this is very important. And basically, we can just combine them together, having the set of tuples containing all of the data from the first tuple and all of the things from the second tuple, but combining every tuple from the first set with every tuple from the second set. And there are also natural joins. If we have some overlaps, because it's possible, like if you have two tables in SQL, it's very rarely you will have some overlaps when it comes to attribute names. So we would just use some very fancy tricks telling us that, okay, if you have an overlap, we could just see which names are overlapping, and if the values from the first tuple matches the corresponding names from the second tuple, then we can basically match those tuples together. There are also like several other type of joins, but this presentation isn't really about SQL, and I'm talking too much about SQL, so I'm only just gonna mention union, which is basically a fancy fancy set theory or way of saying get the results get these results and combine them with these results and treat it as one big result. But we were supposed to talk about transformations. I made a huge deal about SQL. So, well, a lot of the transformation that we are defining could be kind of interpreted as a something similar to SQL, maybe not necessarily in their actual implementation, but at least in the design and the intuitions around them. So for instance, projection. When we have this kind of projection, well, we could assume that if someone told us that, okay, you want to extract the attributes from the table in this particular order, if someone wrote it for them, wrote the order for you, get all of the attributes from this table. The order in which the attributes were defined in the original table is irrelevant. The order in which we fetching the attributes is provided to us by someone or something. Well, this is very, very similar to the situation in which we have two records. They might have the exact same fields, but in a different order. And the macro code, again, whatever, would generate the code, which is basically call the field on every single one of them. The order in which the data would be extracted and passed in the constructor can be automatically resolved. And the value, well, it doesn't matter where the value was in the source, because we're just calling a field. So memory light is not interesting, is no issue for us. The language would take care of it to make sure that, okay, if I want to get the fifth field of this record, I'm just using its name and I'm accessing it. So I can see some similarities to SQL. As a matter of the fact, the source could have even some additional columns or additional fields. Again, when we are generating the code, it doesn't matter. We can have additional fields. The only thing that matters is that for every single field that we need, there have to be some value that we can fetch from the original. Renames. When we have renames in SQL, let's rename this column as this, because whatever SQL processor we have requires us to have those results stored under these columns. Well, this is very similar to the situation when we need to rename a field in our table, which is also something very, very often happen when we are having these data transformations. We have almost identical case classes or records or whatnot, but one of those fields got renamed. So we can just tell that, okay, this field got renamed. If you see this field on the target tab, use this field from the input. So again, we can use those SQL principles when we will be implementing our code with whichever technology we want to basically achieve the same result. Cartesian product. Well, if we had like two record types and wanted to merge them into one record type, which is also something that's happening, well, the Cartesian product is really, really good analogy, because in Cartesian product we're assuming that the attributes are disjoint. So if the attributes are disjoint and if those fields in those records that are disjoint, then it's also unambiguous how we would merge them. The only issue is how we would define the DSL to express this to the code again. But every single language has some way of passing these things around if they are supporting some code generation. But we can also fill in some missing fields. Like if we have, like in one of our tables, we have A, B, C, D, or sorry, A, B, C columns, but we need A, B, C, D, E. Okay, so how we could obtain the missing ones? Well, because we are doing some super mathematical exercise, which is super not necessary, but very nice for the math professors, we can always say that, okay, we are doing cross join, but instead of joining with some actual data, we're doing this in nested select, in which we are hard coding the data, giving them names. Basically, we are creating ad hoc this another set of tuples. And we could also express this with some DSL as when you see this field hard coded to this value, when you see this field hard coded to this value, and this also would be unambiguous to run. But also, if we want to just use SQL without all those functions, we can just hard code those data in a single select, and it's even more easy to run. But with no fancy theory behind it, it would look exactly the same way. Same if we wanted to use function, like this is also like valid SQL. If we wanted to fill those missing fields with running some function, we could also express it in our DSL. So at this point, it's more an exercise of how we would express things in a DSL that our code again would be able to read our configuration rather than anything fancy. But as we can see, so far, all of these things were, could be justified by some principal mathematics, even if it's really simple mathematics that we use every day when we're working with SQL. But those were the easy cases. So let's try something harder. Enums. Not all of the languages have enums, but some of them do. So let's say you have or ADTs, algebraic data types, if you prefer. So what would you do if you had this kind of type? You see that this user type could be either admin with no parameters, or moderator, and moderator have some roles, or user, and user might be verified or not, and depending on the user type, you might give them different access, different permissions. You might fail or succeed their request. And then you have, well, those languages which have some seal traits, enums, ADTs, or whatever, usually also have pattern matching. And this is this really nice thing about pattern matching, that it can be exhaustive. We can check that if every single of those cases was handled. If it wasn't handled, we might fail the compilation, in this way making sure that user handled all of the possible inputs. So it might be useful. So if we had enums, okay, so we have our user type enum, but in database we also have some extra case because we might be writing that, okay, this user is suspended. So if you are fetching for this user, you shouldn't return the result because we wanted to ban them, but we also don't want to delete the data to remember that they were banned and whatnot, but you don't necessarily want to deal with this case when you are looking at the domain. Yeah, so how would we map this user type to the user DB type? If we were writing code by hand, it would be looking somehow like this. As we can see, it's like really dull. That we are just passing things around. The only thing, the difference is that those are the kind of different types. And the nice things about it is that, nice observation, is that when we are transforming records, we always had to fill every single field in the target type. But here, when we are working with enums, we have to pattern match every single input subtype. So there is some correspondence, there's some duality, and it's justified considering that from the category theory point of view, those are products and co-products and they're dual to each other. So you can see this duality right here in our code gen, in what is permitted and what is denied when it comes to hand-waving things. Okay, but this is still boring code. We would like to generate it. So we would, even if it's like kind of obvious how it should work, let's put some math behind it. Well, we can use unions. We can use unions to basically diversify that if we had this type, we should generate this kind of select. If we had this type, we should generate this kind of select, and we have this subtype, we should generate this kind of select, and then we should combine them all. But because this is SQL, usually you have to have the superset of all the possible records that will be passing around, so it doesn't look as nice as when you are looking at the, and also half the fields are nullable, so it doesn't look as nice as the pattern matching, but yeah, the mathematics is still there. Okay, nested data. That's going to be more interesting. So let's say we have some outer record and nested record, and we want to convert those types. We have the outer foo and want to convert it to the outer bar, so we would have to take this value, the inner value, convert it, and then pass it around. So we can do this. So first I should just show you how it could be done if we were writing it manually. We could either just call the constructor manually and manually deal with the inner conversion, or we could just, to make it more, explicit that there is some correspondence, define some inner value, and handle this inner value transformation to make it super explicit that there is a name correspondence between the inner value before and after transformation. And this is basically expressed in the SQL, like if we did some artificial name mangling when we would, just write all of the paths to those nested values as a single string, for instance, inner A, inner B, inner C, then we can see that it's worked the same way as if it was not nested. It just, we need to do some hand waving to turn this nested structure into unnested structure, and then we are falling back to our previous principles how this mapping should work. Okay, so let's complicate it a little bit more. We are merging two nested tuples. Principle the same as before. We will have to merge the inner tuples. This time, half the fields are in the inner foo, half the fields are in the inner bar, and we want to combine them together into inner bus and also inject some extra fields. So the DSL could look something like that, and how it should behave. Well, if we look at this from the SQL point of view, if we convert all of those names into this flattened hierarchy, well, this works exactly the same as the conversion of of those flat records when we just renaming types or providing some missing values. So yeah, like whatever engine we would write here, we could still make it like a real principle and really intuitive to the user how it's supposed to work, at least so far. Even if the case looks like kind of nasty, that like we are two records and we are merging them recursively. It's still principle. We can still like explain this in very simple terms how it should work. So let's handle things even more complex way, like optional values. Like in some languages, if you want to have optional values, you don't want to use nulls, because when you have nulls, you don't know if your value is actually there, or if you are expecting that this is user and you will receive null. So sometimes people are preferring to have some separate option type, or optional, or whatever you call it, or maybe. So okay, now we have a separate type to handle. Like in this case, it's like if when we have this optional type, usually it has like two versions. One of them is when we have the value, and we can explicitly handle with pattern matching or some combiners or whatnot. On the other version, when the value is empty, and we can also handle that some way. But in this case, it's actually like really easy to figure out how it should work. Like if we are having non-optional value and want to lift it to optional value, we can always use some combinator telling that use the version of the option when the value is out there, and just pass this inner value. So okay, it's handled. The other way around might be a little bit trickier, because okay, I have optional value and then transforming into non-optional value. So how to handle it in a type-safe way? And the answer is, if we want to generate this target 2, there is no way to handle it like with a type-safe way. The only way to handle it in a type-safe way is if we use some sort of embedding, which is a fancy little way of saying, okay, we have the set of possible values that you have here, but it doesn't handling all of the cases that we want to care about. So we're extending this set with some extra values that our API, DSL, whatever, would be able to use to tell that, okay, normally we would use your value, but we are seeing that it's not falling under this principle, so let's handle it in some other way. For instance, on Scala 3 there are some types which are used here. Like we can say that, okay, this embedding of A would be value of type A, or value of type empty, or value of error message, because we might just pass just error message, or there might be exception because we are still on Java, and Java always have exceptions which we can cut, but we still they're still not value. We can just pass it around, and then we can pattern match on the result and see, okay, is it empty? Okay, we're doing this. Is it error message? We're doing it, etc. But this is basically a pseudocode. Like in one of the libraries I wrote, it's working slightly different, but yeah, basically we would, in this kind of data, if you would like to convert one type into another, and there is no way of having the safe way of transfer this data, we would like to fail and have some separate code again. We would say, okay, I'm going to convert in a type-safe way whatever is possible, but there are some things that can only be checked at runtime, and because of that, we will use a dedicated separate type which would be handling all of those runtime failures. It will not be, completely, hand-wavy, and it will not do all of the, mapping in the runtime. Mapping is being computed at the compile time, but the runtime failures that can only be checked at runtime, they are being handled on runtime in a separate type. And then we can have a separate code again which would be dealing with those things. So yeah, right now we develop this idea that sometimes when we are mapping between those data, there are sometimes kind of like a JSON encoders and decoders. Like virtually every single time you can encode data as JSON with nothing really bad, like because why wouldn't you be able to encode the data? But when you are decoding data, there are failures, and you might need to handle them. So it's exactly that. You might have like encoders and decoders when it comes to converting new types, and you have to reflect it in your code again. But because we're having some schema, and we can analyze it. We are able to do this. We are able to distinguish those cases when it's always possible to convert the data in the same way, and when it isn't. Okay, so we handled this case. Okay, so let's handle another case, like different naming conventions, because we want to automate as much as possible, but also we want to be pragmatic, but we also want to be mathematical, obviously. So let's say one of the values coming from the project when you're using camel case, and the other from, let's say, some other project which is maybe some code gen which is using snake case. Sometimes you're using protobuf, sometimes you have railguards or whatnot. There's a lot of these code gens that you are using, like IDLs. They are generating code for you to use, but you don't always configure your conventions. But you can see that the code that you will have to write to convert this one into that one will be really, really dumb. Even if those names are not identical, you can see that they represent the same thing. But they don't look the same. So is it broken math? No, because we can introduce equivalence relation, which is something which is symmetric, reflexive, transitive, and create something called equivalence set, which basically means that you can have a whole set of values and partition it into some smaller sets when everything inside is indistinguishable from one another. So for instance, if we wrote some, we define some relationship for those equivalence relation for those names, they are saying all of the names of different conventions, if they're representing the same words, should be the same. So we could partition all of the set of possible identifiers into something where, for instance, some name in a camel case is the same as some name in the snake case and the some name in the Pascal case, etc. And it's a mathematical way of defining, things that are equivalent. And if they're equivalent, we can use this equivalent relation to compare our fields as opposed to just using, equals. And the problem is solved. The only issue is that we would have to define some DSL to handle it, but this is a problem for the people writing code gens. This is some example how it would look like, but, Okay, so far we see that we can, use some declarative way to express how transformation should be resolved. We handled it both for records and enums or products, if you prefer. We handled for nested data. When we have unavoidable runtime issues, we can handle it with them embeddings. So, so far, also if there are missing values, there are also some principle way how we can handle it. So far everything checks. We have good math. There is no way to make it broken, and it should be intuitive for the users, and it should be always working. We are safe. We can just use this knowledge to implement our code gens, and it's going to be working perfectly from the go. Well, it won't, because the real world is kicking in. So, the real world kicks in from the use cases that your environment might be forcing upon you. So, for instance, so far we were handling the records, and we're looking at the fields of those records, which look like this, and it's obvious how it should work. It's obvious for everyone. Is it allowed? Yes. So, do you have any more questions? Yeah. What if my record is inheriting a parent because we are working in Java and we can't have inheritance? And the field I could be using is defined in my parent, and some other field is actually defined not as a field, it's defined as a nullary method. And some other field is also defined, it's not defined as a nullary method, it's just a field, but it's not a field, as a part of the record, it's just something defined in the body of a class, so it shouldn't matter. But on the other hand, you might be looking at, okay, so what is the expectation? So when you would be transforming this source into this target, and you will be only looking at the record fields. One only has D, which is nowhere using on the target, and the other is using fields that don't even appear on those field lists in this other record. So So question to the audience, who thinks that this second example should work and compile? Like, okay. So who thinks that this should be like completely forbidden, it should always fail? Okay, there are some people. And who thinks it should be controlled by some flag or config to handle both cases? Some people. Yeah, so the answer to this question is that whichever options you're going to pick, there are going to be people which are after you. Like, like literally, whatever you're going to pick, someone is going to say, I used that option, and it broke my code, and yeah, we had errors that we wouldn't have if we picked something else. And then you are changing the defaults, and then some other guy comes, you broke my code by changing the defaults. So there is no way, no decision you can make to make everyone happy. At best, you can make it configurable and have, you know, very bold letters telling people, okay, we picked the least controversial defaults, but you can change that. But you know, don't come complaining. You're doing this on your own, explicitly in the code or whatever. Similar case, flattening. So when we have this kind of data, we see that, okay, user has some metadata and normal data. And if we go just one level nested, we can extract all of the fields to transform this user to user DTO. So if we call some transformation, should the user be automatically flattened? Who is for it? Okay, there are some advocates. Who is against it? Some are against it. Who says that it should be like somehow configurable? Yeah, so again, this is one of those things that, as far as I am aware, most, if not all of the frameworks have some way of flattening, and it's always explicitly enabled. And if it's missing, people are very, very, very vocal. So, yeah. Java beans. I am working on on JVM. So sometimes I have to deal with Java beans, or more specifically, some people which are using my library have to work with Java beans. And the thing about Java beans is that you don't have this nice little record which has, you know, immutable values, names to access, just one constructor, thing like that. No, you have to have getters and setters for every single thing, and you have to have internal vars to mutate those things, and you also have to have default constructor to handle these things. So, so things are getting a little bit nasty because you cannot just, you know, call the constructor and call it a day. You'd have to rewrite the code which is internally calling the default constructor and then call setters and then somehow compare the names from the Java bean with the names from the input class, which is obviously possible because we can define the equivalence relation. We can also map it like the other way. We can take all of the call of the getters and use it to pass it to the constructor, so everything is nice, etc. And then you have some guy who decided to use set in their name, because why not? Because set name is the name that we are using in some set of values, so obviously it's very descriptive. So, and our user is extending the name set, so we have to implement this set name saying like, hey, this user, this value belongs to the set of users, and well, now you have ambiguity because you want to convert user to user bean, but should use name or set name. Like the types are checking. Set name is a better name than name. It's more matching the setter. So which one of these two you should be using? In practice, the only reasonable way to handle this is you should fail the compilation telling this is ambiguous. Sorry, you have to handle it explicitly. And you know, those tiny little things that you only learn after you try to make things better for everyone and you made it work for someone. Another thing, this is also like specific to Scala, sorry. So there's this thing called eval, and the basic idea behind it is that okay, I don't want to use strings or integers or longs. I want to wrap it into some type to have it name and to no mistake. Don't mistake my. Don't make a mistake when I'm passing some string around. Okay, this string is username. It's not just a string, so I will not be able to pass it for user address, so things like that. And the eval is some blessed way of doing these things because it also tries to avoid the allocation in the runtime, and virtually every single library in Scala knows about it, so also tries to handle it out of the box by wrapping and unwrapping when it comes to parsing JSON or shoving things to the database. So so it should be easier of all the tools that should be handling records out of the box. So we are expected to also wrap it and unwrap it automatically. So we have some data. We decided to write some special wrapper around optional data to not mistake this with something else. So, okay, when we are converting source into target, those records are almost identical, so nothing fancy. If we're converting this source into optional target, again, nothing fancy, we're just wrapping in the option like we did before. If we are converting one option to another option, we can be smart and use something like map, and internally, derive this conversion. Again, nothing fancy. When we have an option and want to convert it to non-option, we are using our special handler for things that could be optional to generate, some reasonable handling of the situation when something inside is empty. So, okay, no surprise so far. So let's use both of these things at once. We have option, which we want to convert into another option, but this option is wrapped into our wrapper, which should be automatically unwrapped. So we could assume that, okay, we are unwrapping, we're having some option, we should convert it to option, so we're mapping it. So whether it's some or not is irrelevant. We should just expect that, okay, either we receive some or some none, because it shouldn't fail in the runtime. It should always succeed, so this handler for runtime errors should be superficial, redundant, etc. So we have this code, we are running it, and then someone reports a bug that's they received none instead of a some none. This is just an example bit, so after minification. So their case was that they should receive some good, nice runtime data, and instead they received none as if it was a failure. And what happened? Well, basically when we had all of these rules that we defined, if we have option on the input and non-option on the output, we should do this. When we have option and option, we should do this. When we have wrappers, we should do this. Well, the priority of those wrappers is defined in some if-else manner. And if the priorities are wrong, you could end up with a case where, okay, we are converting into the option. So let's wrap source optional into some, and then let's use this rule that if we are safely unwrapping, then we are failing if this is empty, etc., etc. And by the combinations of those 2 or 3 rules, which separately works perfectly fine, you combine it and you get the behavior which is type safe. Compiler doesn't complain. It definitely doesn't match the user's expectations. And this is a special category of things that Hiller is describing as feature interaction bugs. Every single feature on its own works perfectly. Combine them together, everyone is pissed. So, and this is only something you can learn from the users when they are starting working about it, because every single new feature, increase this power set of possible feature combinations, and you cannot even think about all the possible failures that can happen. And this is not something that failed as a compile error. This code compiles. This code returns things. It doesn't complain. It has no exceptions, no nulls. It's perfectly fine, but it doesn't work the way we would like it to work. And that was the last thing I wanted to talk about, so I can summarize that. Well, yeah. Even though when we have these schemas of the target and we want to generate the transformation, we can define some principle to work with them. This way it could be deterministic. You can look about it, understand it, like, you read the specs, and even without reading the specs, majority of the cases should be like, and you understand, okay, this is the way it should behave. If it behaves anywhere else, it's a bug. Users might bring some expectation about the types, like how options should work, how some errors should be handled, and yes, you can still encode those expectations into your principled and simple and understandable model of mathematical relationship and stuff. But then in the real life, sometimes you might have cases when there is no obvious behavior because every single user would be expecting something different. And there is no way to mathematically encode different expectations. Like, sorry, it's not possible. And sometimes you will have feature interactions back where every single feature on its own works perfectly, but their combination, well, technically speaking, it's not an error, but the behavior is not matching people's expectation. If it's not matching their expectation, it's still a bug. So for me, it was a kind of interesting journey to learn all of things when I was implementing this library, because when it comes to code gens, it's very, very difficult to come up with more dual idea that, okay, you have a record and just copy fields from one to another. Like, you cannot imagine a way this can get wrong, but as more and more people come to you and want you to solve their problems, you have cases which are absolutely simple, and it will be, will butcher your behavior. So the takeaway I have is that you can have really good mathematical definition, and it can be principle, and you can go to the conference for the functional programmers, explain this, okay, this is not just some hand-wavy code written with some if-elses, nulls, exception handlers. It can be actually principle with some solid mathematical foundations. The model could be as simple as possible to encode all of these values. Every single rule should be like immediately obvious, and you still will get some really, really nasty cases because no simple solutions is, on its own is able to handle the complex of the reality and the complex expectations of the users. And this is completely not related to any particular choice of the technology. It's just the complexity of the domain at hand. So, so thank you. So, are there some questions? Sure, yes?
My question is it possible to define those mappings to be reversible? So in the first example on this slide where there's map 3 times, I'm mapping from API to domain and then from domain to DB. And it's very often the case that I have some, let's say, business logic encoded in DB. For example, user email must be unique. It's best to check on the database level. And then I need to unwrap this error because the database says user.email constraint violation, and then the domain says user.userdata.email must be unique, and then it should say user.credentials.email already taken. Is it possible to make this mapping reversible?
So from my experience, yes and no. You can write the code gen in such a way that you have this very well-defined principles that you could, for instance, run 2 code gens at once, from A to B and from B to 1, and have such a DSL, such a way of passing the data, how this should be handled, that it would be running 2 code generations at once in parallel, and report to the user if one of them is missing something, and have those combinators rename is obvious. Like if you are renaming A to B, then you are also renaming B to A. So things like that. But then you can have things like when you are providing new value because some old value is missing. You can see that when you're transforming A to B, A is missing this kind of value, but when you're turning B to A, it's missing some different kind of value. So very quickly you can see that even though like on the code and implementation layer, it's very, very simple to implement something which is bidirectional. In practice, you will very, very quickly get some cases where you would have to do something like handle one side of the transformations in this way, handle the other kind of transformation in this way. So very, very few cases could be like easily handled with no special cases like that. Even if you are doing any sort of round trips to make sure that those things are working the same way in both directions. Even if you introduce this, you very quickly will run into some complex cases which can be just easily handled.
I have a question. So
yeah.
Given the highly principled nature of these transformations, were you able to use property-based testing, or are you encouraging your users to use them, the answer to any of this is yes, then do you have some experiences when you were able to find some non-obvious bug with this sort of testing?
So as far as I know, some of those libraries, besides having the code gen for the implementation, also have some sort of code gen for the tests to make sure that the tests are doing whatever it's needed. But those tests, I guess, should also be kind of, reviewed by the human, make sure that they're doing what they do. My experience tells me that you definitely want to have tests. Whether you write this code by hand or use some AI agent or having some explicit code generator which generates some classes, it puts them in some managed directory of your build tool or using macros or whatnot, you want to have it tested. Like every single code gen, not only this one, every single code gen, because basically every single code gen comes with some assumptions, and some of those assumptions in some complex cases might be really obvious. So if you want to make sure that this code is doing what you want it to do, you have to write tests. The advantage of using a code gen is that you only have to maintain tests and some very small config, as opposed to maintaining both tests and some very, very long code that you would have to, modify every single time some, requirement changes. So, but it also is case by case. Like I had the cases when I used a lot of code gens, it was great, and I had the cases where the code was so highly customized that there was no way of using any sort of code gen. So I cannot really tell you that you should use one or the other approach. Yes?
Have you identified a set of language features that the user can safely use, having some kind of guarantees that the transformations will follow the user's intuition, and the constructs where the intuition starts to break and becomes more problem?
Well, I believe the experience might vary, but it definitely helps if you are not using stringly type approach. If you use some way of having separate types for, let's say, usernames, user address, etc., and if you are also using smart constructors, things like that, then you can have such a code that you can only allowing, I don't know, turning data only in a corresponding way. With some, you can have a whitelisted set of when this is allowed to be transferred into this and back, but not into some other type. And then when you have this code gen, it would basically fail to go beyond this whitelist of your custom wrappers about the primitives. But this on its own requires you to invest a lot of time for writing wrappers for all of those primitives. So some people loved it because it saved them debugging. They see, okay, if I try to pass username as a user email, it won't compile. So it's cool. Code gen also cannot generate the wrong code. It's cool. But for some people, it's just another boilerplate. So it really depends on the developer's perspective and if they find it as a feature, saving time, or a nuisance. Yes?
How do you use a mathematical model for the library? Like if you just do it as a design diagram, or you combine the data structure, the case class into mathematical model, and you apply the SQL approach for them and have the transformation?
So those principles that I described, they basically are result of spending a lot of time working on the library, especially because at some point, for a long while, the library was developed in a startup way. So we need a feature. Let's add some few if else's, and it's gonna work. And then some bug appears because the if else's are not enough. And then we're doing some refactor, and then we're adding a new feature. And after a while, this code became unmaintainable. And we had to write it from scratch. And then when we were writing it from scratch, well, it was easier for us, and it wasn't necessarily easy. It took several months, but it was easier for us because we had an extensive unit test suite. And when we were looking about all of the requirements, it was appearing to us that we should try to have some principled approach to certain things. And when you look at the stuff, and when you look at the unit test that, okay, this fails, so we need to fix it. This fails, we need to fix it when we implement that. It started occurring to us that there are some repeating patterns, and those repeating patterns usually could be described with very simple mathematics. It's just sometimes you have to do some adjustment to adjust this complex user case into the simple underlying logic. Yes?
I think you touched upon this like when you mentioned any val, and also like in one of your answers now. At the beginning, before any code gen was introduced, you were saying that if I'm writing this manually, my type compiler may not help me, right? Because it's not able to tell the first name string from last name string. So in languages where you can do this, you basically create a type for first name and last name, even though they are still strings, right? But the compiler then will tell you, okay, like you use last name in the context where you should have used first name, right?
Yes.
So that's like a practical thing. But I wanted to talk about this, like it's a declarative approach, right? So you gave us like many examples of this. One thing that's kind of bugging me there is, so I'm declaring like this field, we are hard coding to a value. This field, we're, I don't know, lowercasing, or something else. And everything else is not touched, and it's as it is in the original, right? But what if I'm actually interested in one of those fields, right? And I need to read the whole declaration and find that it's not there, then it means it's not touched.
Yes. Like.
Was there like at any point in creating the library? Was there a point where you wanted to have like this explicit, these are the fields that should be taken from there and not transformed in any way? Like I'm just listing them here so that they are listed, right? And maybe like later when I refactor like the original type, I also know that I need to like list it also here because it's like the compiler is telling now, okay, this is basic, right? Or you change it, but by default it's now also in here and you didn't think about this.
Okay, so in this exact format, we never had a request for such feature, but we had a request for a similar feature, especially people coming from Java and MapStruct, which are using this declarative way of documenting how their transformation works. So they don't mind that they don't have to list fields that are moved as they are with no extra work from your side. But they had a really big issue about fields that are silently discarded. So there was a request which we implemented about some sort of policies that if there are fields which are available in the source but not using the target, you can define that, okay, I want to explicitly ignore fields that shouldn't be used. And if there is some field that I haven't used, but it's not listed explicitly by me, compilation should fail and say, this field is not used, and you haven't marked it as something that should be ignored. This kind of request we have slightly different from what you were talking about, but similar issues arise, let's say.
Okay, so nobody had problems with defaults being defaults.
I would say
That's interesting.
with this kind of defaults, no. When it comes to Scala, in Scala you can have something like default values, and you can have something like, after a while we decided to have an opt-in flag that if you are using default values and there is no source, there is no corresponding field in the source, you can fall back on the default value. This kind of things we have. When it comes to the defaults as in default behavior, I would say no. Probably people who would not like this approach when you're trying to have the like in a way, what those code guns are doing is they are trying to generate the minimal amount of work to convert one type into another. And so when you are traversing things recursively, the trees, when the types are matching on the input and the output, then you can say, okay, this is a stop condition for the recursion. Like we don't have to do anything. So for a lot of people, that is enough. That's okay. Like if they want more, then they could write unit tests, because they still have to write unit tests, and this is something they would find there. Any more questions? Okay, so thank you again very much.